Have you ever asked yourself before, what exactly is time? And what is time specifically? I mean, Einstein's definition of time, which is supposed to be a fourth dimension in the universe, why can't I see it in front of me? Why can't I choose the time I like and move through it comfortably from the present to the past or to the future, just like we move comfortably through the other three dimensions that make up the entire universe, which are length, width, and height? What does it mean that we have this fourth dimension, which is time, and we cannot see it with our eyes, and we cannot move through it except to the future only? And also, how am I supposed to be living in the present when in fact, to see anything, light takes time to reflect off it and then reach my eye so I can see that thing? Doesn't this mean that I'm seeing its past, especially if that thing is very far from me? And thinking can take you even further than that, and you start to doubt that you are living in the present at all. There are things that may be intuitive for people, but if I asked you about their nature, your brain might stop for a moment until you gather your thoughts and answer, because we take them as something intuitive and accepted, and we do not even try to think about them. Let's try this. If I asked you, for example, what is time? You might stop for 10 seconds and answer me. Some of you will say that time is the past, present, and future, the months and years. Those who followed me well will give a more accurate answer, which is that time and space are one thing, known as the fabric of spacetime that makes up the entire universe, and that time is relative according to the speed of the object and its mass and their effect on this fabric. Just as Einstein proved in the special theory of relativity that if you traveled in space at high speed, time passes for you more slowly than if you stayed on planet Earth. If you have a twin brother living on Earth, he will age before you. In addition, Einstein also proved in the general theory of relativity that if you lived on a planet with a mass greater than our planet, like Jupiter for example, time will pass for you more slowly than it will pass for people on planet Earth. Today, I will talk with you about time itself as a physical concept from the perspective of quantum mechanics and the theories of relativity. Since ancient times, humans began to notice certain phenomena that repeat continuously throughout their lives, so they began to take the repetition of these phenomena as dates to infer important information in their lives. For example, the phenomenon of the moon appearing in different shapes throughout the month was the first phenomenon used to determine time and dates, from which emerged the lunar calendar, which was divided into about 12 or 13 months a year. A little later, we started to see agricultural operations, so the solar calendar appeared, which depends on the seasons of the year in which the Earth revolves around the Sun, a complete revolution every 365.25 days approximately. This calendar was necessary so that people in the past would know when to plant and when to harvest. Not only that, but also so that there would be something agreed upon among all people and we could set dates for everything. These two types of phenomena for knowing time are still being used until now, approximately. But the point is that the time we know now is more accurate because it is divided into seconds, minutes, and hours, which began with the scientist Galileo when he invented the pendulum clock. Before him, there were many other tools for measuring time accurately, but what we rely on until now in our daily lives for measurement is approximately similar to Galileo's pendulum clock. So, as not to get you into too many details, all this talk about time and methods of measuring it changed completely at the beginning of the 20th century. When we come to talk about time, in our current time, of course we place the concept of time in a scientific context and separate it from linking it to specific events and mere changes that occur in space. And we talk about it from a purely physical perspective. When we want to see time in physics, we will definitely see it on two levels, which are the theories of relativity and quantum mechanics. But before them, I must tell you that Newton believed that time is absolute and constant anywhere in the universe and does not change at all. The year that passes for someone living in another galaxy is the same time that passes for someone living on planet Earth. But this was proven wrong by Einstein in the special theory of relativity, and he said that time is a fourth dimension, and it is not constant or anything, but it is relative. This means that you can say, I am walking in such and such a place, and you can also say, I am walking in such and such a time. Wells was not wrong when he said walking through time. But what happens when you walk through time is that time experiences dilation according to your speed and your mass. You will say, does your talk mean that everyone walking at a certain speed has a certain time passing for them? I will tell you yes. But the important point here in the matter is that you are walking through time from the present to the future only, and you cannot go back to the same time you were in. You can never go back to the past. To be precise, you can theoretically go back in time to the past, but this is impossible to happen because you will need to exceed the speed of light, and then only. So, as not to get you into too many details, you can watch the episodes of Special and General Relativity and Time Travel to understand the coming part more. Let's go back to our topic and start with the best definition of time, which is that it is considered a continuous process of progressing events from the past to the future through the present. Time moves in one direction, which is the future. Everything we see around us moves in one direction only. For example, when you cook an egg, you cannot return it to its original state in the past. The Big Bang itself began, and the universe is still continuing and expanding until now. Ice cubes, when they melt, we cannot go back in time, so they turn back into ice, unless you put them in the freezer, of course. We can say that time is like you are shooting an arrow that does not stop, and the direction of the arrow is always forward. This is the concept of the arrow of time. Nice? Not really nice, because the idea that time has a direction in the first place, that time does not exist in the laws of physics. Of course, you are surprised now, but indeed, time is not treated in physics as a vector quantity like force, for example. But the idea that time moves in one direction, or the idea of the arrow of time, we all observe it and know it. This idea is also associated with something else in physics, specifically in thermodynamics, which is entropy or chaos. The second law of thermodynamics says that any system moves in one direction, which is randomness or chaos, and entropy is the amount of change in this randomness. Let me explain one by one so you understand. The egg that you cooked in the fire has moved from a state where the energy in it is very concentrated to a more random state, and you cannot return it to an egg like before. If you brought ice and left it for a while, you will find that the ice melted and became water. The opposite is, if you brought water, it will never turn into ice on its own unless you cool it. This is because every system moves in the path that will increase entropy or randomness. In other words, energy is always used in one way, which is from the state where the energy is concentrated or organized to the random state. Now someone will come and tell me, but the ice that melted, we can put it in the freezer again, and it will turn back into ice. This seems logical, but it is wrong. Because you will have reduced the entropy of the ice, but you increased it somewhere else, which is the refrigerator. Because the refrigerator will use energy to cool the water for you and turn it back into ice. So you will still have increased entropy in the end without realizing it, my friend. Also, this entire universe has entropy increasing in it day after day. From the days of the Big Bang when the randomness or entropy was very small, and with time it began to increase and energy spread everywhere. This means that if you want to go back in time, what is required of you is to reduce entropy. But this is impossible to happen. This is the same thing that happens with time. It moves in the direction of the future, and we cannot return it back to the past. If you want to return it, you need to ride a rocket that moves at a speed faster than light. And this is of course impossible because light is the maximum speed limit in the universe. After this talk, someone will tell me, well, could there be a relationship between entropy and time? In fact, we cannot be certain that entropy is the reason for the existence of time or vice versa, but we can say that there may be a link between time and entropy. But to be sure of the existence of a link, or even a relationship between time and entropy, we need to understand what time is as a physical concept more deeply. To understand it more deeply, let's move to the second level of physics, which is quantum mechanics, and see what is the story of quantum and time. We know that the theories of relativity apply to large objects and the world around us that we can see with our naked eyes, which is called the macro universe. But quantum mechanics describes the world at a very small level, which is the atomic and subatomic level, which is called the micro universe. Time in quantum mechanics, if you took a video, for example, and played it in reverse, you will notice that time goes back. But if you did the same thing at the levels of quantum mechanics, like atomic interactions for example, and reverse the interaction tape backwards, you will not notice any differences. You will not notice that there is time going backwards at all, and you will see the same exact interaction. This is because what you will see is something that repeats, whether you reverse the tape backwards or moved it forward. It is just like the movement of the pendulum, exactly. If you filmed a video and watched its movement and tried to rewind the tape backwards, you will not be able to distinguish whether this movement is the past or the future. That is why there is no meaning to time in the concept known to us at the quantum level. Physicist Jeff Tolleckson, in his conversation with the program Closer to the Truth, says that the past and future at the quantum level travel the same distance to the present. If you have a particle moving, it moves from the past to the present in the same way it moves from the present to the future. Imagine that the atoms and small particles have their absolute time that is different from your time completely. This is so serious that the scientific community until now is in debate around interpreting the meaning of time as a physical term. This is the same difference in the concept of time at large levels in the universe and small ones, and even at the level of the universe itself. Some deny the existence of the past, present, and future, and consider them just an illusion, including Einstein himself. He says they are just words in the human mind, and that they also exist at the same moment. In reality, the past, present, and future do not happen one after another. No, the three happen at the same time. All we need to move between the present to the past or to the future, which always happen at the same time, is to change our speed. In a research paper entitled The Quantum Mechanics of the Present, physicist Alexia Alfevs says that the present is nothing but waves of unknown probabilities. As soon as one of these probabilities occurs, that probability has already become in the past. All the probabilities exist at a certain moment in the present, and they all disappear, and only one probability remains, and that is what you decided to do. At that moment, it turns into the past. I want you to imagine this idea as if the universe is a big book containing all the probabilities, and you have your small book, and you take from the universe the probability you chose, which is your present, to increase the information in your book. You are always heading towards choosing to increase information to increase your book. This is the same thing that happens approximately in entropy. Increasing entropy means increasing randomness and increasing the energy that has been used, and increasing information to describe the entire system. In the end, there may indeed be a correlation relationship between time and entropy, and our awareness as humans of time at the level of the macro universe or large objects. But the truth is that scientists are still trying to find a unified theory that defines time for them more deeply, especially since it is greatly linked to human consciousness, and this is what increases the difficulty of understanding it ideally. I have finished, and I hope you enjoyed the episode. As usual, I will leave the sources for you below the video in the description. If you are interested in science in general, and physics and astronomy in particular, do not forget to subscribe to the channel to follow the new topics. I will see you soon in a new and useful video.